Once more, good day, good people. Right? Now, let's look at this other case now. Here, I've got an alcohol, right? C bonded to OH, that's my alcohol. Then I'm like, what other groups do I identify here? Can you see here? I've got CH2, CH3, that's my ethyl group. This one is Me, that's my CH3 group. This one, it's my pH, that's my phenyl group. So can you see here now, I do not have a CN group. So what happens in a case now like whereby I've got two alkyl groups and an aryl group. I've got two alkyl groups and a phenyl group, right? So as I've already indicated here now, like when we identify here, we've got an alcohol. We've got alkyl groups, right? Which is our methyl group and our ethyl group, and then we've got our aryl group, which is the pH group there now. Like. So in this case now, like, what does this mean? It means that like we've got three possibilities to initiate what? To initiate a disconnection. Now the question comes now, if we've got so many possibilities, which possibility is going to win over the three possibilities? Just hold it right there, right? Let's first explore these possibilities. Let's take possibility number one, right? So what do I mean by those possibilities? I can initiate this disconnection here. I can initiate this disconnection here. I can initiate a disconnection here, right? Because there are three different groups in this case, right? And there is no silent group, right? It's alkyl groups and a phenyl group. So let's look at possibility number one, right? I shall call this possibility number one. So with possibility number one, what's going to happen is here, this can be broken here. So this is where we can imaginarily break down this target molecule. This is our target molecule, remember? Right? Now, if that is the case here, now, like, what am I going to get here now? Then these are the arrows because I'm moving backwards. So what do I get here? A C bonded to O, bonded to H, 1, 2, 1, 2, and then there's my pH, right? And then here, this is my methyl group. So meaning that now like this carbon atom here is going to be what in charge? Positive, right? Then plus what there? Plus what on the side? Plus, can you see here? I've got a CH2, then that has taken these two electrons here. So this means I've got a CH2 minus, that is bonded to what? That is bonded to a CH3. So I've got an ethyl carbanion. I have generated a carbanion, ethyl carbanion. Now, what happens here again? Still the same thing here. What happens here? I've got a positive charge, single bond, and oxygen, which is a source of what? Electrons. And therefore, this will come over here, right? If I were to move backwards, and then what do I get here? I will end up with a carbon that is doubly bonded to what? To oxygen. Singly bonded to what? To hydrogen. One lone pair, the other lone pair now like has been used. Therefore, oxygen becomes what in charge? Positive in charge, right? And then here, this gives me pH. This gives me my Me, what call like group, right? So from the chemistry that I've done at first year level, when I look at this reaction, I automatically know that like this must have come from a Grignard reagent where your carbon here is a carbanion. This must have been a CH3, CH2, negative, MgX, can be bromine, it can be whatnot. So let's say bromine, this must have been a Grignard, what call like reagent. Like if I am applying now like the chemistry that I've already studied at first year or second year or third year. Again here, oxygen is positive in charge, and oxygen is much more electronegative than what? Than hydrogen. Therefore, it takes away the bond pair that it shared with what? With, if I were to go back, then what do I get here now? I end up with a C that is double bonded to oxygen, 1, 2, 1, 2. This is bonded to pH, this is bonded to Me, right? Then plus the hydrogen here falls off without electrons, therefore it is H plus. Now the Grignard agent, we know that like the Grignard agent comes from what? From stage 3, stage 2 in this case. Let's say if this was bromine here, ethyl bromide, alkyl halide. Alkyl halide treated with magnesium, right? Dry conditions, right? And then in diethyl ether, then it gives us this Grignard agent. So this is where the Grignard agent actually comes from, right? So all of this now like is my what? This is my retrosynthesis. This is my what? Retrosynthesis, right? I have been able, right, to what you call like imaginary, what you call like break down this molecule into smaller, what you call like components, right? So now, once I've reached this state now, like it means that now like I can reassemble these, right? And assemble these now like, so as to what? As to synthesize my target molecule. Let's look at my retrosynthesis. I mean, let's look at my synthesis here now. How will my synthesis look like in this case? This is my synthesis in this case, right? So it means that here I've got my what? My C, double bond O. This is my pH here. This is my Me here. 1, 2, 1, 2. So this here must have been treated with stage 3, stage 2, MgBr, right? In the presence of what? Of H plus, right? So this could have given me my what? My target molecule C bonded to pH, bonded to Me, bonded to Et, bonded to OH. So this must have been my synthesis, like basically. If I wanted to, I could have even like have gone back to go and trace where this one comes from, you know, like, you see. But in any case, you see, like, this would be my synthesis, right? Right? Now, like, in terms of synthesis now, like, how do I show the synthesis? Then I would have to give you the mechanism now, like, of that particular synthesis, right? Let's go and see this, the mechanism. So the mechanism would be, the mechanism in this case would be, I would have C double bonded to oxygen. This is my pH. This is my Me. Then here CH3, CH2, right? Negative. This is MgBr, positive, isn't it? And then here the carbanion is the one that comes and attack here, right? Because this carbon atom, the carbonyl carbon atom is what? Is electrophilic. Then this here goes out, right? Then we generate a tetrahedral intermediate. This gives us C bonded to oxygen, 1, 2, 1, 2, 1, 2, negative in that case. Then this is our pH, this is our Me, and this is our stage 2, stage 3. And then close here, there's my intermediate. Then what do I have outside? Mg plus, what call like Br, isn't it? Then this is now washed with H plus with acid. So if you wash this with acid, the O minus will go and pick up the H plus And then what do we get here now? We get C bonded to OH, 1, 2, 1, 2, bonded to pH, bonded to CH2, CH3, bonded to Me. So which is our target molecule. So I have managed to assemble, to reassemble the what? The synthons, right? You see, like to design what? To be able to design my synthetic route to my target molecule, right? Organic chemistry is easy, organic chemistry is beautiful, organic chemistry is fun, right? Let's do this. I'll see you in the next class. Thank you.